Yeah. So hi guys, this is Hackanoon. We are hosting a podcast for Holochain. I have Arthur Brock and Eric with us. In a second, we'll be speaking to these guys in terms of what is Holochain, how is that going to help the community around decentralization and management of innovative products that possibly could be highly scalable and usable for the people who want to have solutions tomorrow. Without wasting a lot of time, I would let Arthur and Eric, like one by one, tell us a bit about themselves and see like what is it that these guys are up to these days. Hi guys.
Hey, thank you for having us.
Yes, thanks indeed for having us. This is Eric.
This is Arthur. And yeah, Eric and I actually met doing alternative currency work, community currency work back in 2004, before the cryptocurrency world took off, and have been building various solutions in that space and sharing them open source through the Metacurrency project. We, in fact, I think we are interested in currencies in a way that most people are not, I think, in that we are, I think, use that word in a much broader sense. Like if you think of it a little bit more like currencies, like the ability to see currents, right? That we create currencies, whether they be reputation currencies, college degrees, postage stamps, event tickets, all kinds of things to manage currents, to manage flows. And many, if not most, are actually not tradable, are not monetary currencies.
Right.
But we, when we talk about currency in English, we use that word sort of interchangeably with money, and money occupies such a huge space in our imagination, kind of like it's almost the only way we think about it. And so what we've been interested in is really how do we collectively shape currents, flows for a better world, for greater collective intelligence, for coordinating, collaborating better. And money is a part of that picture, but it is not the whole picture. So that's some of the background with which we've been coming at this from. Eric, do you?
I think what I would just say to add to that then is that Holochain is where we've come to after a very long time and a lot of intense effort in understanding those patterns of how to create distributed collective intelligence, tools for distributed collective intelligence. And Holochain is our answer to being able to do that. And one of the things that you can do inside that context is monetary currencies. And the way we've been implementing that or thinking about that is what we call mutual credit currencies. So we can talk about that a little bit later. That is one of the kinds of tools that you can build on top of a truly decentralized architecture for creating distributed applications.
So like, as you can see, like just based on these introductions, it is a mouthful. People need to be explained what it is, especially the people who might not be technologically aware. Even the word blockchain like has turned off a lot of people. I was speaking to the guys at NEM the other day, and they were like, the blockchain is a bubble within a bubble. And like Holochain tries to like maybe have a spot adjacent to that smaller bubble. So like, how do you guys think you could make it easier to understand for those of us who might not get it? Like, why should I use Holochain? Why should I care about it?
Well, I think large-scale coordination is not a bubble, right? Like that is just something that's fundamentally necessary for the world that we live in. And now there may be fads within large-scale coordination of things that become popular at different times, or solutions that people see as possible, or think might solve problems. And I think blockchain is one of those fads, if you will, like where people are seeing a lot of promise. They're liking the idea that it's possible to take the power out of the center and be able to have something that's more decentralized, that where the power can be more evenly spread around. But the architectural approach that blockchain takes has a bunch of limitations in terms of scale and speed and that kind of thing, which we could get into. But where all of our work was grounded is the patterns that we see in nature, in biology, in physics, right? You have trillions of cells in your body that are coordinating this massive accomplishment, right? Without having to synchronize everything to a global ledger, it seems, right? So there are clearly architectures in which large-scale coordination can happen. How do those architectures work? And how can we take advantage of those kinds of patterns?
So let me give a couple examples of that might be really very straightforward.
Yeah.
So, okay, so you have Facebook, and Facebook is a tool that people use to coordinate by creating Facebook pages. And all of a sudden you have a neighborhood group. That's a great thing. And so people can use Facebook to create a Facebook page and have a neighborhood group, and you can create one for your babysitting co-op, you can create one for your club, for your church, whatever. But what's the problem with that? The problem is that that application is deeply centralized and you are the product, right? The product is the people who are using it. And what Holochain does is it provides a technological framework where it is possible to have the same kind of ability without having Facebook in the center. Now, the architecture of that is complicated and difficult and requires us to use the kinds of inspiration that Arthur is talking about thinking about how biological systems do decentralization. We can't talk about that without getting technical, but we can talk about the fact that what we want is the kind of power of coordination that Facebook and Twitter and all of these other very large-scale applications provide that does not require a central corporation to own the protocols and the server power and also monitor and run that. So instead, what we do is we create a framework, a way, a set of protocols that allow application developers to create, you could call them games. We call them DNAs in our world. You create a DNA, which is, it's literally like a DNA. It specifies the rules of the game for one tiny little game, whether that game is showing something like a small Slack that you can then run in a decentralized way with your people who are running Slack, or if that game is a micro Twitter, or if that game is a currency, or if that, again, I'm saying that word game in quotes because it's a game, a set of rules that we can play by. But if you use the architecture that we're talking about, once you've created the game and you've decided, and by you, I mean a group of people have decided to play that game, you all say that you're playing it, it's peer-to-peer among those people and just those people. And
nobody can really stop those people. Right?
Just in the same way, if you get together and you are living in a neighborhood, nobody stops you from saying we're going to have a babysitting co-op and we're going to share our resources together and coordinate. But this can happen at a global scale. It can happen globally at very large scale, but also at small scale, but globally, because we can leverage the power of the networks to do that without requiring there to be a corporation to own the protocols and own the servers. That's the key value.
And this is nice to hear.
Is that like, it should be simple enough, I hope.
Yeah, it is like simpler for me, like because I am a doctor by my degree, so I like get the biological references, and I like did my background research on Holochain, so I understand like what you mean when you guys talk about a DNA or an immune system, as you will, and how does that fit in terms of large-scale coordination. And a follow-up question over here would be like, I guess it ties into your concept of DHTs or decentralized hash tables. And how does it compare with the DHTs that we hear about in terms of torrents or whatnot? Because that is something a lot of people understand. They understand peer-to-peer transfers. When we talk about large-scale coordination, for a lot of these people, it could just mean downloading the latest movie. Like, although that's not legal, but I guess that is a reference that people understand. So how does Holochain compare to that? Does it improve upon the torrent protocols? And like, I guess like I should let you guys like let us know about that.
So yeah, BitTorrent, as you mentioned, a file sharing platform, and many other file sharing platforms use DHTs, distributed hash tables. And so do we. We use distributed hash tables. What's interesting about all that is distributed hash tables are actually a more mature technology than blockchain. They've been around longer. We've practiced scaling them larger. We know how to shard them, right?
Right.
Where blockchain sharding is a non-trivial problem because most blockchains are trying to manage consensus. When you break things into parts that can't see each other, you have the problem of how can you actually manage consensus? Well, Holochain does not manage consensus. Holochain actually is set up more the way the real world works. Again, we look to physics and biology for this. And DHTs are just the strategy for the shared data space, if you will. So in blockchain, everybody has a copy of the same ledger, and you have to keep all of the copies in sync, which is why you need to manage consensus, to agree what the next set of changes are that everybody has to accept, right?
Right.
When you have when you have an agent-centric approach where everybody has a copy of the DNA, just like in your body, every cell has a copy of the DNA, right? The cell changes its own internal state according to its instructions. It doesn't need permission from other cells, right? And then it broadcasts information through a number of different protocols, through ATP, AZP transfers, and through hormones and neuronal signals and maybe infrared light or ultraviolet light, or like there's a whole bunch of ways that cells seem to communicate with each other to coordinate. But then the other cells have their set of rules that they're following and comparing things by. So in our system, we have our DHT is a little weird. It's a mutual validating DHT. So first of all, let me be careful when I say our DHT. There is not one monolithic one. Like on blockchain, every Ethereum dApp and all of the transactions that occur in ETH and other coins that occur are on one blockchain. In Holochain, there is no one Holochain. Every application, which has its own DNA, creates by the hash as a key of that DNA, like the hash of the code that everybody is running. That hash becomes sort of the network key and is part of the encryption of the network, so that every application is a separate network and a separate DHT, a separate shared space, right? So that you can, in Eric's example, you can use like a Slack team, and you can choose to make that a private Slack team. Or you could use a Twitter type of app, and that could be a very open app. And you do that, you manage that by how addresses can join the network, right? And so you can make it public or you can make it private, but it first of all, that's the first level of sharding, is that every one of these things run the same rules, but within a single kind of organism, if you will. The DHT becomes the organism that each of the cells, the nodes running the DNA, are creating together. And the DNA is just our shared space, in the same way that in blockchain, it's the ledger is the shared space. But not everybody has to hold the whole thing. So it scales in a completely different way. And yet anybody, all you have to do is trust your own copy of the DNA. Anybody can validate anything. Right? We're not even subject to a majority attack. right? In that if you and I are doing a transaction in a monetary currency on top of Holochain, I can audit your chain for myself when we're about to go do this transaction. I don't have to trust that others on the network said this was a valid transaction. I can check for myself the state that you're in, right? And so it changes the dynamics in such interesting ways, and that it's almost like the more you know about blockchain, the worse off you are in understanding Holochain. It's kind of like if you think about the way natural systems work, like they're closer to the way Holochain works. And if you think about the way distributed computing normally works through consensus, then Holochain tends to confound you, because it's like you can't get your mindset out of the consensus. And even in the examples you brought up about BitTorrent and most of the file sharing systems, they tend to use centralized trackers to tell you who's holding which files. So one other big difference with our DHT is that we gossip the data by hash to the nodes. We send it to the nodes whose their address in the same address space is near that hash, like it's closest in numeric order to that hash, if you will. And then that lets us always make requests by reaching toward the people whose address is near the thing that we're looking for. And it becomes a self-balancing, self-healing network. And the data gets gossiped around, and nobody has to hold it all.
Let me just give another angle in on the original question you asked, because Arthur said things that are they're exactly right, but I want to give just another perspective so you can have kind of binocular vision on the notion of a DHT and what's different about what we're doing. One way of looking at what Holochain is it's the composition of two very tried and true bits of computer science technology. The hash chain, which proves that you've done a series of operations irrefutably. Git uses this, it's been around for a long time. And blockchain uses the exact same thing with the linked headers. So you combine that, the hash chain, which allows individual agents to act autonomously and make declarations about a rule set. You know, it allows them to say, I'm playing a game of chess and I'm following the rules and this is my turn. So I add something onto my chain. So I have that irrefutable chain. That is something that you can do in an agent-centric way. Now you combine that agent centricity with saying, okay, now I made that declaration and now I'm going to publish it to the DHT. So instead of storing a file, what I'm storing is an action according to rules. As long as the other agents who are playing the rule have the rule set, and you can check that by the hash of the rules, then you can get from this DHT the actions of other people that are necessary to validate that those are legal actions. So we're combining this distributed hash table for getting the declarations of individuals and checking them as a society. So it's the combination together, the appropriate combination of the individual agency and the social agreement space mixed together in those two technologies. That's what the combination is that's unique and interesting about Holochain. Does that make sense? It's like having both sides of that as a key in integrating ability.
No, definitely, it makes sense. Like, I had these questions because I was working with a friend back in the day, and he is like trying to use Holochain itself for his banking solution. Like, he wants to connect all of the banks in Switzerland, and he wants to make sure that all of the data is managed via DHTs onto Holochain or maybe IPFS. So he had that confusion. I guess like Arthur is right about that because a lot of us arrive from that space. So talking about Holochain, understanding it needs a lot of relearning. For him, it was like IPFS adjacent. For me, it was like, is it something similar to Hyperledger Fabric? Like, you see that we are trying to draw parallels instead of trying to imbibe what like Holochain is trying to do on its own, instead of like trying to see, okay, so those guys are doing that. Is it similar to what you guys are doing? Got it. So like on this topic, like how do you guys like what is your opinion? Like in my words, about Hyperledger Fabric or an IPFS? Like, what do you guys think about these technologies?
Well, personally, I like IPFS. We've been kind of fans of IPFS all along, and we started off trying to use their, well, the first version of Holochain did use their libp2p library, and we basically had to rebuild their DHT framework as we tried to use it and that kind of thing. But we were, trying to play nice and sort of be able to operate in kind of a collaborative space with IPFS, although as the name implies, interplanetary file system, they're more focused on files. And in many ways, Holochain is really more behaving like a distributed database. Right. Where we're trying to empower apps with rapid database updates, which is not at all really the way IPFS is organized. Right. And when you start going into Hyperledger or any of the other blockchain-like patterns, I mean, there's the issue of consensus again. Right. You also mentioned in a question I saw beforehand, Hashgraph. In some ways, Hashgraph feels like it's a little hybrid step in our direction, in that they acknowledge that agents are a part of the picture, and they sort of have this gossip about gossip, protocol, but their focus is still on consensus. Right. And therefore, their protocol hits a wall when you hit a certain number of agents because of the exponential explosion of gossip about gossip about gossip, right? If you have N agents and then you have to have N agents have the information about all the others' gossip, now we have N squared, and now we have to have the next one, we have N cubed, right? We start having an exponential complexity function. Right. And as you start getting more than 200, 250 nodes, that just starts to grind to a halt because the exponential complexity of it.
It has become so huge.
Yeah, exactly. But if instead what you're doing is validation about a local state change, instead of having consensus about global state, you manage validation of change of local state. And anybody has the rules, so anybody can validate. Right. Then you can, it just changes the game. You can validate it immediately, like very quickly, have some set of randomized peers, randomized by the hash algorithm, be able to validate it and store it in the DHT, because we only propagate information in the DHT that's been validated. Right? You don't gossip the invalid information. No, go ahead.
So this is very interesting, and like a lot of new learnings for me, as well as I hope for the HackerNoon readers. Like, can we go by an illustrative example of sorts, like maybe you become a transactor, I become a transactor. When we transact, and let's say like Eric wants to verify that, and like maybe when we talk about if you know the rules of the game, or if you know like what are the rules by which we are playing, he can verify as well, we can verify as well in our local state changes. Like, let's try to do that with an example of sorts, because I like the direction where this is going, and like this would be very, interesting for a lot of people to use that.
Yeah. So in your story, if we're doing a transaction, and so first of all, if you're in the network at all, then you have a copy of the rules, right?
Right.
And in fact, in your local source chain, that you are the only one who can write to your chain, and it's a history of your actions. Nobody else's actions are in your chain. Only your actions are in your chain, right?
Right.
And which is different than the DHT, but you have to publish to your chain first, and then things get published to the DHT. So what's interesting?
Is this my DNA?
Well, the DNA is the rules of the game, and your chain is using the hash chain to declare the actions that you have taken. But the thing that makes it all be provable is that everybody who's playing the same game always starts by committing the very first entry to their chain is the DNA itself. So when you go back and you verify somebody's chain, you always land back at the same hashed item. And therefore, you know that they're playing the game that you're playing.
Well, you know they have a copy of the correct rules.
Yeah.
Right, exactly.
Whether they're playing by those rules or not is a different question. If
That's true.
Holochain is open source. If you hack a version of Holochain to allow you to run a different set of rules while pretending to be this set, right, then you would be misrepresenting in that regard. But and you would be able to write any change you want to your local state. But the problem is, if that change in any way doesn't follow the shared rules that everybody else has, as soon as you publish it to the DHT, then it's going to fail validation. And when it fails validation, depending on flags you set in the application, the nodes who reject the validation can wrap a little envelope around it and say, that we call a warrant, right? And say, person, this node is corrupt. They're propagating invalid moves of the game, if you will, right? They're cheating on the transaction or cheating in the game. And they can pass that warrant to other nodes who can check it against their own copy of the DNA. They can look inside, they can see the person's move or the transaction that they tried to do and see whether or not they validate it. And so then that's the beginning that you mentioned before of the immune system. That's the beginning of the immune system response, right? So if you hack your node to let you spend money you don't have, for example, right? Then anybody can see your chain. They can audit your chain transactions when they have this transaction that goes past the money that you can spend. Everybody can see it's an invalid transaction. Right? Because those are all changes to your local state. Your own chain goes plus, minus, plus, plus, minus, minus, minus as you do different transactions. We can fast forward through it and see your balance, right? So it's very easy to validate whether or not you have the credits you're trying to spend. And if you don't, then any of us can warrant it, and then everybody can basically add you to their blocked list and you're dropped. So even if you can cheat on your local state, nobody else, what you've essentially done is fork yourself into an invalid chain state that nobody else accepts. So it's just like if you were a Bitcoin node that, commits a block that won't pass the other nodes' validation rules, they just won't accept it. You're just forking yourself into a reality nobody else will play with you in.
Right. Got it. So like in the Holochain side of things, maybe like, let's say your local chain is a reflection of your actions. And like, if we can verify that, see like what are the pluses and minuses, and if they do not add up, it is a clear sign that, like, let's say that the actor could possibly be a bad actor, right? And then the rest of the actors could flag it.
Exactly. There's another thing that's very interesting about this model too, which is not really what ends up happening in the blockchain world, is that it allows you to scale the effort of validation according to the value of validation. So in the world of blockchain, it's designed for absolute anonymous action. And it's like the ultimate level of security where anybody can do anything, which requires very high validation and very high checking. Whereas there are many, many scenarios of distributed applications that we want to create in the world where you might not need to do as much checking as you might need to do in other cases. So from the point of view of creating applications that scale globally, according to the size of the user base and are able to be used in different contexts, it means you can also create validation rules that are tuned to that level, to the level of the importance of actually checking things to that degree. Because if you are doing a babysitting co-op, or you are doing, let's say, a small Slack group, who's going to cheat in the group of people who you're using? Why even waste the computing time doing that? It's silly to do that. And so but you still want to be able to have a distributed application that can play in that global way without a centralized company in the middle owning it.
Yeah, for example, a tweet needs a lower level of validation than $1 million Bitcoin transaction, right?
Mm-hmm.
Like you don't want to spend the same computing power, invest the same amount of running that infrastructure. So you're burning, 0.5% of the planet's electricity just to be able to do 5 transactions a second, right?
Right.
But the other thing,
Because I bought a cup of coffee with my Bitcoin. Terrible idea, right? From a collective standpoint of what is a smart way to be using our resources in the world, that's a bad move.
Right.
You want to be able to scale it according to the use. You might want to do that occasionally. If we need to send $1 billion between 2 countries that hate each other or really are not aware of each other, and they can't trust each other, and they'll trust the blockchain, okay, fine, maybe.
But the other thing about this validation is that in blockchain, it's trying to be fully preventative. Like one way that I think about this is we have driver's licenses. We drive down the road, right? It's a very dangerous thing to be hurtling in tons of steel. You can kill people with this, right? But we don't always enclose cars in concrete barriers that say you must stay in this lane and you can't change, right? Like cars can change lanes. Not only that, but if maybe you just have a little dotted line, a little line on the ground that's between this car and the oncoming traffic, which if they hit each other would be a very bad thing, but we pass all the time without hitting each other, right? And so in some ways, it's like the blockchain approach to distributed apps is everybody has to be driving inside concrete barriers at all times. And the Holochain approach, because you can change your own local state, and you could theoretically hack your own node, is more like the DHT serves as kind of like the traffic cameras that can see that you drove on the wrong side of the road and we can revoke your license. You know what I mean? Like we can't stop you from driving on the wrong side of the road. You can drive past that painted line, right? But then everybody can say, we're not going to play on the same roads as you anymore because you're dangerous, right? And so it's a response rather than a prevention is one of the options, right? And that's still just as strong an option as long as you can protect your own state. And so part of how this works in the way that we recommend people implement currencies on top of Holochain, that's a little bit different, is instead of like a single party send where I sign my coin and say who it's being transferred to, we recommend actually countersigning a transaction. Both parties commit it to their chains because both parties' states are changing. And then they hand each other their headers as the counter signature, right? So you have, I can see if we do a transaction, I have your header, you have mine, right? And that was our proof that we have both changed our state. Now, if you were spending 1 million credits and you want to try to double spend those credits, you might want to not publish this transaction to the network.
Right.
But I, on the other hand, who received 1 million credits and your header, have a strong incentive to publish this to the network. And you can't stop me from publishing it to the network. And therefore, the network has the knowledge of your state. And so if you try to roll back your source chain, which is a hash chain, what happens? Well, you break that header. You have a different header that points back to the same previous header, and everybody can detect a chain rollback and say, "Guy's cheating, and we're not gonna play with him. He's trying to double spend."
Got it. This was like really helpful. And speaking of like dApps, so like I know that there are a couple of things that you guys are developing yourselves, and let's speak about that. And a couple of other dApps that you guys think could be something that maybe the world will get to know more about in the coming months. What side of technology are you excited about? I ask this question because whenever we think of dApps, we automatically think of gambling on the blockchain, and that like takes us into a whole different thing. Whereas like dApps could be so much more than like just gambling, right? So yeah.
Yeah. it's funny. There's people either think of financial apps, tokens or gambling. There's not or trading apps like in idea, decentralized exchanges, that kind of
Mm-hmm.
thing. But what we're trying to do is basically say, look, everything you do on the internet is an app.
Mm-hmm.
It are almost never interacting with static data.
Right.
What are the things that you do on the internet? You go to Wikipedia, you go to LinkedIn, you go to, whatever. These are all database driven websites.
Mm-hmm.
Right? And typically the content is provided by the users. These are Web 2.0 apps, right?
Mm-hmm.
Facebook, Twitter, all of these things are Web 2.0 apps. As Eric mentioned earlier, you don't need to have a surveillance company in the middle. Right?
Right. Agreed.
And so therefore, what Holochain enables is completely peer-to-peer replacement of those kinds of things. But we don't think currently about blockchain dApps that way because they can't scale.
Right.
But if you could think of taking all of the things you already do on the web and just taking the company that's, sticking advertising in front of your face and selling your data to advertisers or blocking you from your own customers. Like Eric was mentioning Facebook, it's like all these companies that early on moved some of their, like they pulled their community into Facebook because they're like, wow, everybody's on Facebook. We can have so much more reach. And then, short time after, Facebook started charging you to reach your own people, right? That were
Yeah.
following your product. And that's because that's what happens when somebody else is in the middle of the relationship.
Right.
You put somebody else in the middle of your relationship,
We all know what happens.
Yeah.
So,
Got it.
so there are
Yeah.
a bunch of interesting things that are people who are building things on Holochain. There are
Mhm.
some folks who are doing stuff in the energy world where
Mhm.
you want to be able to control at the edges energy production and actually coordinate when air conditioners are turned on so that they're not turned on at the same time, so that you decrease peak loads in a neighborhood. And so this is some work that's happening in Australia. A company is called Red Grid, and they're doing some very cool stuff that way. That uses that kind of decentralization to be able to coordinate the activity of energy flow. Arthur mentioned Wikipedia. I would love to see some wikis, and we've got some folks who've been doing some very cool wiki design. We're using hierarchical wikis that allow you to create wikis in this way. I myself am funding some work that I'm really excited about being able to do coordination of distributed projects using tree-like structures for your management of how to create and manage a project as you go on with a product called Acorn. There's a bunch of other things that people are excited about. Arthur, you want to name a couple of the other ones that?
Yeah, one of the projects that I think is going to surprise people if we can really get it taking off is Holo REA. So REA stands for a certain type of accounting that actually a lot of people haven't heard of. Like everybody knows about double entry accounting.
Right.
But double entry accounting by definition is bounded by the walls of a single organization, right?
Right.
Because you have to have offsetting debits and credits based on the type of account, and the types of accounts are defined within the walls of an organization. Right. But if you and I are doing a business transaction, right, like my accounts receivable is your accounts payable. That's also a double entry transaction
Right.
of the sort, but it's across organizations, right? So REA is designed for that type of accounting. It stands for resource, event, agent, right? So it's basically to have economic agents produce economic events that involve the movement of resources. The resource may be a currency, a resource may be a case of whiskey, hours of a service, reaching a milestone on delivery of a project, or like you can define these things in the ways we already all do in business, right? We already have various units of account that we run our businesses by. What becomes interesting about Holo REA is that your accounting First of all, your transaction, you both countersign the transaction, right? So your transaction becomes your signed, immutable, auditable accounting, right? Which then also has the possibility, because you're committing it to an immutable ledger, and you could operate these things in certain shared DHT spaces, it creates the possibility of any business's unit of account to become a cryptocurrency. Not through the issuance of some token that means nothing and then you're trying to like convince people it has value, but actually because I produce these cases of whiskey. And if people will let me basically borrow from my production by going into debt in cases of whiskey units, and they know they can use these credits out there in the world at any time, they can redeem them for cases of whiskey, right? Then we have a currency essentially by this kind of mutual credit accounting. As soon as you allow somebody to go into debt and borrow against a balance, you've just actually created a currency.
Right.
But this isn't creating a security. This isn't creating some new security class of token, right? This is just accounting. And so in the ways that I think blockchain currencies are going to be running into regulatory hurdles all over the place, where people are trying to put protections in place from people ripping people off by creating new tokens and trying to hype them and sell them and all that kind of stuff, right? Accounting is legal everywhere, right? And so if you can put an accounting framework in place that actually starts empowering businesses to extend lines of credits to each other, well, what just happened there? We basically took accounting and have started cutting out the middleman of the banks and all that kind of stuff, and we can be doing transactions through this kind of direct peer-to-peer accounting. And
the other thing that does, just to land this even more powerfully, is that it creates currencies that are not speculative. It creates currencies that are based on actual production. So people for a long time have been in this world and wondering about why in the world do we have all these currencies where you have the government can issue as much as they want whenever they want, or the ones that are issued in blockchain that are issued, it's funny, in the blockchain world they call their currencies non-fiat, and government currencies are fiat, but blockchain currencies are actually also fiat. They're declared out of nowhere. They really are declared in from no thing. Whereas if you do this other pattern of creating mutual credit currencies that are based on productive capacity, then you're actually creating something that represents actual value in the world, and our economics can become based on value rather than speculation. And of course, some value is speculative, right? You may be borrowing against your future production. And so there will be some speculation on the value of that, but at least it's represented directly by the productive capacity, which is a crucial thing. And then it means also that the supply of the currency can be based on the supply and demand of the productive capacity.
Got it. This sounds interesting. I guess it's more of a conversation for my father, who is a chartered accountant. But I guess it makes sense when you talk about that blockchain, it's still fiat, and what you guys are doing, it's just accounting, which possibly could create more trust in a decentralized or a distributed mechanism. So it makes a lot of sense. And I guess you guys have to jump off to some other call. I heard this beep go off, so I would try to wind it up with these last questions about remote working. 2 minutes each for you guys. What's your advice to people who are now starting to work remote? The three of us, I guess we have worked remote for a long time. What about the rest of the world? What do you want to tell them?
Well, something that I would say, especially amidst these times of the coronavirus and that kind of stuff, where you can actually start to see the fragility of some of our systems, right? Is that resilience is a real thing, right? Having systems that are peer-to-peer and can't be shut down, don't have centralized points of control or enclosure, is important,
right?
And may be able to fill gaps, real gaps, when there are breakdowns in some of these centralized infrastructure, which can happen for strange reasons like we're currently seeing, but it can happen at any other time that a company decides to pull the plug on something and no longer offer it, or they go out of business, or, you know, local disasters, or, you know, all kinds of things happen where centralized infrastructure breaks down.
Mhm.
So that's one thing that I would say. But another thing that I would say is, even if you are a little uncertain, if there's something you want to build and you're a little uncertain whether you're ready to make the jump to something that's so decentralized and sort of so bleeding edge, you can build your centralized system to be compatible with changing over, right?
Mhm.
If you, instead of using a SQL relational database type thing, if you build on like a MongoDB, a document database, and especially if you use hashes, so you have content addressable storage, if you use hashes as the keys for that key value store, and if you use something like GraphQL to talk to the back end, right,
Mhm.
then you can talk to Holochain. You can build a centralized app that you could come around later, and it would take very little work to replace the centralized database with a
Mhm.
decentralized, completely peer-to-peer framework, and still keep all of that work you invested in the UI, right?
Mhm.
And so I'm just saying, if people are thinking of building things and want to have a future to move in this direction, but aren't ready to make that step yet, there are things that you can do that are very low risk in how you
Mhm.
design projects today to have that kind of future.
Got it. Thank you very much, Arthur. How about you, Eric?
Well, I feel like the question you were asking was more in the social realm, and I like Arthur's answer, of course, because yeah, I'm excited about doing that kind of development, obviously. But to answer uh, your your social question, we have been doing at Holo and Holochain, we've been doing the distributed work for a long time. We have people all over the globe in all time zones, and what I'd say is it's honestly actually rather difficult. There's a bunch of difficulty in coordinating. And so one of the things I would say is be patient. Be patient with the fact that time zone differences are hard, and try to group yourself into groups that don't reach across too many time zones. The resilience thing that Arthur said is also true. Use a bunch of different tools. Use Mattermost for your asynchronous communication. Use lots of Zoom. Give yourself more time on Zoom or whatever you're using, because Zoom is clearly getting some centralization issues, as we've been finding right now.
Yeah.
Use a number of them. Also have the other tools up your sleeve and ready to use. But be willing to spend a lot of time in those places. We at Holo, we have co-working sessions where we just keep the room open and we chat and we work at the same time. We actually have the dance party that people do on Zoom. We have what do we call it?
Nice.
We have happy hour, which is half an hour of happy time that has nothing to do with alcohol, but you just get together and chat. We do a bunch of things like that that create a space for connection that happens automatically that you have to do intentionally. In our Mattermost, which is one of the open source alternatives to Slack, we have a gratitudes channel where people just put in what they're grateful for. And we also have a delights channel where people take photographs of things that they're excited about. We have these other things that create the human fabric that bring us together. And I'd say experiment with those, play with those, because out of these things, we will actually end up finding the seed sources of what will get incorporated into the kinds of distributed apps that we're going to be building that we need to do. So we have to play with them now. It's a great opportunity for it. And really we do need to be patient with ourselves because it isn't easy. It really is a big challenge.
Definitely. Like, I guess I was reading somewhere that all of these like big companies, like the Slacks and the Ubers of the world, they were founded during the last recession. And now that we are in the midst of one right now, maybe there is a lot of innovation like just around the corner. So like we have to be optimistic about certain of these things. And I would be like very happy if like Holochain is like one of those guys who like literally take the world by storm, and like uh, we would like to have to like we would love to hear more about it, like see you guys get a lot of recognition and see how that goes from there.
Thank you very
So
much. We hope so too.
Yes, thank you.
So on that note, like we'd be signing off. Thank you, Eric. Thank you, Arthur, for like joining the Hacker Noon podcast, and like we hope to have you guys soon back over here. Thank you very
Thanks.
much.
Thanks again. Thank you.
Thank you.